Jak? Ja bym zaczęła, bo YouTube to nagra, tylko powiem, że byle było nagrane, a tutaj no właśnie. Jestem komputerem, wiesz, to jest bokowi też jest.
Wydaje mi się, że też mogło być jedno to, że trochę ludzi było więcej z przodu ewentualnie.
Spoko, ja zaraz pójdę, tylko właśnie powiem, że...
Good morning, everyone.
Good morning.
I'll make myself louder. Yes. Good morning. We will begin now. Apologies for the delay. Apparently, it's a very tricky location to find and the room to enter. And welcome. You have no idea how thrilled we are that you are here today and we can meet in person and share knowledge, experiences, and network throughout today and in the evening. We will have plenty of presentations today that you can learn from. This session is on life science, and the last one is on engineering and mathematical modeling. Yes, great variety, and I hope you'll enjoy. I will call now first speaker of today, Consul Joanna Rataj, to say a few words on behalf of the Polish Embassy.
Dear ladies and gentlemen, on behalf of the Polish Embassy in Denmark, I am honored to inaugurate this scientific conference. We are proud to participate all together with Biofrontiers and Polonium Foundation in organizing this great event. And as I stand here, I would like to express our sincere thanks to our partners. And our special gratitude goes to Mrs. Edyta Biskup. I think she isn't here. Yes, we would like to thank her so much for fruitful and friendly cooperation. Ladies and gentlemen, I would like to say also a few words. Yesterday I had this opportunity to talk to those of you who attended the event at the embassy. And like my colleagues from work, I myself was very, very impressed, not only by your knowledge, by your achievements, but also by your passion. And as we all know, passion is a driving force in our lives, and nothing great can be achieved without it. So may the passion always be with you, may it lead you to new scientific discoveries, research, and I wish you wonderful and interesting lectures, and of course I wish good luck to the speakers. Thank you so much for attention.
Thank you very much. Kasia Makowska from Polonium Foundation.
Hi everyone, good morning. Thank you so much for joining us for today. As Agnieszka said, my name is Kasia Makowska. I'm the CEO of Polonium Foundation. So we are an organization that is built by the research community for the research community. We bring together the scientific and research diaspora from all around the world. So we are not based here in Denmark. We are a bunch of volunteers spread in Europe, in the UK, but also in the United States. So if you see today people that are a bit maybe confused by the location, but are very excited to be here, this might be our team. Please make sure you find them and say hi. We'd love to meet you. And we are extremely excited to be partnering up with Biofrontiers for this event. So thanks a lot to Biofrontiers for all the hard work for this event. Thank you so much for the embassy for their support, to the speakers, and to all of you here in the building, but also in the live stream. We are so excited to have you, and I wish you an exciting meeting full of, bringing back the in-person interactions, sharing experiences, and networking. And we will also have a short presentation about our organization after the lunch break. So I'll tell you a bit more then. Thank you.
Thank you very much, Kasia. And now it's time to hear from Biofrontiers, Krzysztof Piotrowski.
Welcome everyone to First Science Polish Perspectives Meetup in Copenhagen. I'm very happy to see that you made it here, even though the location is a bit remote. I'm very excited because I think we have a very nice lineup of speakers today in all kinds of fields, and I think everyone is going to find something interesting for them. Of course, it's his first event post-pandemic, so it wasn't very easy to organize, and also we should stay careful and please use hand sanitizers and make sure to network, but with all the safety precautions. And now that all the borders are open, I think we should try to use this opportunity to unite scientists all around the globe. And I'm happy that Polish scientists participate in this exchange very actively. If you want to go to Polish and community and industry, so if you like we are work with everyone. And, well, I would also like to thank you, Embassy, for yesterday's event, which was absolutely amazing, and Polonium Foundation, who were of tremendous help to us, and partnership that we built, I think, is going to last, and hopefully is going to bring more events that hopefully
Fun facts about our event today. 5 participants signed up. 50% of our speakers are women. So we are really doing the equality this time. And the Foundation and on. So please today, start, relax, keep calm, not, and let's carry on. I want to introduce our very first speaker. His name is Anushri in innovation, and she's a Scrum Master. What is Scrum or a Scrum Master? Scrum is a theory, or not even a theory, it's a concept in management, sales, developing products. And the Scrum Master is a person, and the role is to get rid of all the obstacles required to go. So this is what Anushri is doing. She has over 6 years of experience in IT and in variety of roles, such as leadership and development. And when she's not working, she's singing and writing poetry and music, and trust me, I've heard her sing, and she can sing really beautifully. Today, let's give a warm welcome to our very first speaker, Anushri, in her talk about skirts and pants.
Thank you for the wonderful introduction, Agnieszka. Good morning, everyone present here. I know it's difficult to wake up early on a Saturday morning to hear some bunch of people talking about why and what am I going to speak behind that. I remember my grandma used little amount so that I could buy myself when my parents were not. And she would tell me words which did not have pockets. From then to now, we have actually gone away from using paper money to going cashless. What is using paper currency to having it all on your mobile phones, we have come a way. I will start about trends in the last decade. Over 3% in 2020, but it still holds the majority of the sales. Debits continue to lead the segment, surging contactless penetration, mobile payments. These are one of the highlights of in-store payment methods which we still are using. Phenomenal growth in e-commerce, especially in the last 2 years. And that is going to continue eating away the brick and mortar stores. As we increase post-pandemic surge has online payments. Now making digital payments real-time, digital remittances, app wallets like App Store and Google Play, they all have become a very integral part of our lives now. Card payments are here to stay, and they are still growing at a rate of 1.8 trillion. The credit card companies have a very high credit appetite and a robust reward program, which is fueling this industry. Like I said, pandemic is accelerating digitization, and we cannot stop it. So the payment industry has advanced at least 3 to 4 years during the COVID-19 era. And this is going to have a massive consequence for years to come. Online retail sales has surged a record-breaking of 14.4% high in the total US retail in 2020. E-commerce is chipping away the brick-and-mortar retail as smartphones attract a rising share of digital shopping. Mobile proximity payments, like peer-to-peer networks, they are accelerated to 131.36 billion USD as major wallets add users at a record clip in 2020. So what is the future of payments? I'm going to play a short video here for you to take a glimpse of the same.
What do developers build on the SendGrid API? A service to send a password reset to a confused customer.
The future of payments used to be all about the next big gadget, a watch, a ring, a phone. But now at a major fintech conference here in Amsterdam, gadgets are a lot harder to come by. That's because one of the biggest trends in the payments industry is called biometrics. All you need to make a payment, your face, your voice, your fingerprint, maybe even your heartbeat.
Hello, Nomi. Please verify my identity.
There we are. Successful. Now you'd be able to go ahead and continue with the payment, whatever you're doing with your day.
Go ahead and buy something. It's that simple.
You were literally just using your face and your voice to make that payment.
Face and voice, you always have them with you, can't forget them.
Instead of entering a PIN or a password, you would use your face, or the voice is another option.
Verify my identity.
Biometrics, like your voice, are increasingly being used to authenticate payments from devices like mobile phones. And thanks to home assistants like Amazon Echo or Google Home, voice payments are becoming a fast and easy way to make purchases without ever leaving the house or even the sofa.
It's basically teaching computers to understand your voice and match that voice to your identity. So that now through a simple voice command, you'd be able to say, Alexa, please buy so-and-so for me. And then Alexa would be able to say, yep, that's Steve Ritter's voice. I'm going to go ahead and make that purchase for him.
Research shows voice assistants are most commonly used to seek information, like the news or the weather, and to play music or videos. But retail is becoming a bigger function, with 35% of consumers using voice to buy products like groceries, home care, or clothes. The voice shopping market is expected to grow to $40 billion in 2022, up from $2 billion today. And right now, it's dominated by a few big players, Amazon, Google, and Microsoft.
If you become, as a provider, like the top payment method of one of those large platforms, the probability that you really outbeat everybody in the market is quite high.
Sorry, I don't know that one.
But there are still obstacles to making purchases with just our voices.
Just as easy it is for me to make a payment using my voice and my Amazon account, somebody else could use that to make purchases either for theft or maybe more importantly, money laundering.
Some experts say biometrics aren't the problem. They're the solution to making payments safer.
The most common password is 123456. Biometrics actually changes the consumer experience and actually makes it more secure too.
With a recent survey showing 93% of consumers prefer biometrics over traditional passwords, it might not be too long before voice payments go mainstream. Hey everyone, Elizabeth here. Thanks for tuning in. What do you think about the future of payments? Would you use your voice to buy something? Let us know in the comments section. And be sure to check out more of our videos over here. Talk to you later.
So this video was from one of the conferences.
There's a lot to learn when you're a new parent, like
that took place in Amsterdam. Now, pandemic has accelerated the industry. But what is the backbone of this acceleration? It is artificial intelligence. One of the very interesting concepts in AI is the conversational AI, which is very fast in taking over the market right now. It is going to take 1.3 billion USD market capitalization by 2025. There are a lot of companies which are using conversational UI chatbots to improve customer experience. They have experienced increased online sales and have experienced high return on investment while investing in these AI chatbots. One of the very biggest Scandinavian insurers, that is Trug, has partnered with Boost.ai to actually make all the queries in-house as well as customer queries automated. And they have actually reported a surge in their sales and also resolution time for in-house employees using the chatbots to a 90% faster rate. Then we have In Financials, which is a part of Alibaba Group in China, who have extensively used chatbots, specifically conversational AI, to accelerate sales within the region. The top countries by usage of chatbot are US, Australia, UK, Netherlands. Then we have AI used in fraud detection, which is the one very critical area that AI solves problems in. Traditionally, we have rule-based systems where the identity of the fraudulent activities is known based on past behaviors. But when AI comes into the picture, using machine learning approach, a user's banking patterns can detect anomalous behaviors. Leading companies in this area are Fraud.net, Iovation, Featurespace, and Signified. So Fraud.net is a leader in AI-powered enterprise risk management, where they identify transactional anomalies and pinpoint fraud using AI, big data, live streaming visualizations. Iovation is one of the world's largest and most precise database curator of reputation insights and cryptographically secures multi-factor authentication methods. Featurespace is one-of-a-kind company that uses behavioral analytics and detects frauds and risk management in financial services. Signified is world's largest provider of guaranteed fraud protection. Moving forward, we have computer vision-powered payments. We already have face detection features which are being used in mobile phones right now. But now the face detection is also being used to authenticate your identity while making payments. Amazon's Deep Lens technology enables cameras to check out grocery items without going through the cashier. So basically, a hands-free, cashier-less facility. Amazon Go has started its stores in the United States. On a similar lines, there is another supermarket chain in Asia called MobiMart, which has completely self-service check-in feature. And you will not find a single human being in the supermarket. Trigo Tech is one of the niche companies who enable such kind of hardware along with AI-powered softwares to make such supermarkets a reality. Now, we saw about voice-enabled payments in the Amsterdam conference. The leading players in this area are PayPal, Venmo, and Square Cash. Although there is still a little bit of hesitation in adopting voice-based payments because of security reasons, still we have 28% consumer base as early adopters for voice payments. 44% of the consumers have already shown interest in voice banking, that is making transactions through banking websites using voice. And 48 million voice payments have already been done, which shows the promising nature of the voice-based payments. Now, AI cannot be limited to only one area or industry or domain. It has innumerous possibilities to solve problems of industries. Now my question to all the people, because most of you, I suppose, belong to academia, is how can we use AI to solve critical problems in the field of healthcare, making driving safer, transforming how we learn, help us be smarter about energy consumption, and helping wildlife. With this, I would like to open the discussion with all of you.
Thank you very much, Anushri. Questions, please. Proszę bardzo.
Thank you very much. Great talk. So definitely AI is the future of the project, as you said. But so can you maybe elaborate a little bit more about the safety? Because on the one side, the AI will allow us to do it, but on the other side, you mentioned that AI will be also used to protect these purchases. So how do you envision these two branches kind of going together?
Simple answer would be,
Anushri, could I please ask you to repeat the question? So
Okay.
everyone, we are sure everyone heard it.
Okay. First of all, thank you for the question. The question asked is, where on one side AI is helping us transform the payments industry, and not just payment industry, every other industry which AI can help solve issues. How do we see the parallel fraudulent activity along with the solutions that AI is providing? How to basically solve the frauds that will come along with the AI technology? Right. Okay. The easy answer would be, since I come from the IT industry, my analogies are going to be from the product development area. So the easy answer is going to be, we will always have testers along with developers, and we will always have hackers along with people who are creating things to save the world. And these two areas will always go hand in hand. And when AI is making things easier, say for the payments industry, I will take the example of voice-enabled payments. So when you are making payments, somebody else, there is always a risk that somebody else can use your voice to make payments on your behalf. And that will again be solved by intellectual property, or I would say GDPR, because it's something which is very personal to you. And regulations like these can actually help us, I won't say curb it totally, but minimize the risks associated.
Thank you very much. We have Krzysztof.
Thank you for your talk. What about the size of the data? Because the thing is, let's say, of course, the password 123456 is very simple and easy to break, but this is very small data set, pretty much because we're talking about huge amounts of people who are in the database, and biometric data sets, they're much more complicated, and the storage becomes a problem, and it generates huge energy consumption. And how do you approach that problem? Because with 8 billion and growing population, storing all the biometric information for everyone, that would be an enormous task, and I don't think anyone could achieve that.
Okay, so if I understand your question correctly, you want to know how can we solve the problem of data storage which is being generated?
Yes, like how do we limit the data we need to store to make sure that biometric security works?
Yeah, I think we can not limit the data because we are living in the knowledge economy, and we are constantly generating enormous amounts of data which actually is beyond our control. What we can do is we can extract the information out of that data which is relevant for us, and then keep that secure with us. So I think it would be judicious to say that we do not store everything, but we basically segment out what is important to us, because information is not useful in its raw format. And every information is not of use to the industry, basically. So we have to develop methods. I think the methods have already been developed by researchers where we can churn out information that we require and discard what is not relevant for us.
Thank you very much. I have one question.
Yeah.
Would you pay using your voice?
Yes, why not?
Yeah, why not? Okay.
Why not?
Thank you. A food for thought for everyone. Think about it. Maybe we should make a survey later. Thank you very much, Anushree.
Thank you. Thank you so much. So here's my LinkedIn profile. We can always connect on LinkedIn. Thank you very much, everyone.
Thank you. We will switch microphone and give it to the next speaker now, please. And as this is taking place, a few words of explanation that I forgot to deliver earlier. Speakers are strongly encouraged to stick to the time limit, which is 20 minutes for presentation and then about 5 minutes for discussion questions. When the presentation ran for 18 minutes, so 2 minutes to go, I'll stand up. So please pay attention to me. If you reach your speakers, if you reach your limit, I'll come and join you here. So just going to hang out with you for a while. I think it's going to be a little awkward, but let's see how it goes, okay? But please be on time, because respecting time is a great quality of a good speaker. And yeah, time. Julie, can you give it a go and see if it's working? Yeah. I'll put the presentation. Oh.
I brought my phone.
You did?
Yes.
You're stealing my job.
No, I don't think so. You'll have plenty to do.
Okay. Here we go.
Yes.
Julie Gerlings. Julie is currently doing her PhD at Copenhagen Business School on the topic of automated decisions and explainable AI. Julie has a background in photography and imaging, but then switched to machine learning and explainable AI. She also holds a master's degree in business administration and information systems. She's an eager tech enthusiast, biohacker, and gadget lover. And listen to this. Who knows what a biohacker is? You do. And Julie does. And she is a biohacker because I just learned she has 3 chips in her hands, responsible for doing things for her. It's extremely fantastic. It blew my mind this morning when I spoke to her. But yeah, so that's Julie right there. So imagine.
It's because I lose my keys all the time. So
that's it. So there is one of them is a key. So please, warm welcome to Julie.
Thank you, everyone. Thank you for the very nice introduction. I'm going to talk a bit about my research projects, and to keep things at a nice pace, I have 4 things for today. So just a bit of introduction to XAI, explainable AI, and the current research that I'm doing. Then I will go into some debates that are occurring in the field. And then I will tell you a bit about the recent research study that I did and the framework that we developed out of that. And just to give you an idea of where in the field XAI really is, it's like in the middle of something with artificial intelligence and human-computer interfaces, and then the social science part. So it's very much about how we can learn a bit more about the algorithms that we are using for automating decisions. And what I'm doing is I'm focusing in on high-risk decisions. So my cases are currently within healthcare and within finance and detecting fraud, actually, as we just heard about earlier. But first of all, why do we even need explainable AI? And you could say there's a lot of reasons why, but there's becoming more and more regulations saying we should know what example these neural networks are doing if we want to implement them in more formal systems. We should also be able to give an explanation if your loan was not provided to you, or if you are deemed with having cancer or a serious illness based on a decision that was partly made by a machine. So those are the things, and then obviously this nice little image here is because sometimes these models are wrong, and XAI can also assist in that sense. So what is it really? And going back to the first slide that I presented about in which area are we, this is a try at giving audience an explanation that they can understand. So it's very much about context, it's about the stakeholder of this decision, and it's about creating something that we trust in, rely in, but also can use to support our human decision, right? And potential benefits of this further on, these two, it can be used for verifying algorithms, it can be used for understanding different kinds of errors. As in this picture, we, for instance, have a detector showing huskies or wolf, and really it looks like it's doing a really good job. It only has one mistake, right? I don't know if there's a pointer here, where it detects that it's a wolf, where it's actually a husky. To me, I can't really tell the difference, but you probably know, right? The issue is that if we look into the algorithm and see what kind of features does it actually use to detect this, it has nothing to do with the actual dog itself, but more the background here. So these are the pixels used. So instead of generating a really good husky versus wolf detector, it has generated a really nice snow detector, because there's snow in the wolf images and not in the husky images. So in that sense, understanding errors that are underlying in your data sets, in your predictions, produce causality and not only correlation measures for explaining models. As I mentioned previously, accommodating rules and regulations as is very prevalent in both finance and healthcare. Also, the big question of why, for example, I did not get a loan, or why I am diagnosed with cancer is a huge thing as well, which leads on to the trust issue, right? So how do we do all this? Because XAI is a bit of a fuzzy field, and there's lots of different methods for producing outcomes that we can actually use to something. And in general, I try to use this input process output image, where you have some method that belongs into the pre-modeling explainability phase. So it's before you actually build the exact model you want to use. And it is related to feature exploration and data analysis and so on, where the goal is to understand in depth what am I putting into the model. And then there's the process, so this is in the machine room, right? and that could be with the goal of designing a model that we can actually understand. So a linear regression model is easier to understand than a neural network. And then the post hoc modeling, where we can look at individual instances. So if it is you who didn't get the loan that you applied for, we can look into your exact case and then see where do you belong into a cluster. And this is an example of this. So imagine that you have a pool of data points, and you have just been applying for a loan. You got rejected, so all the crosses are rejected, and all the circles, dots, are approved. The thing is, you don't understand why. And the reason why we have this really weird form here is because this is actually just a piece of a very complex model. It could be a neural network, for instance, where we have just zoomed in on the section where you belong. So this cross is you here, and then what this line here does is that it makes this sparse linear regression on a local sample and says, okay, so if we want to tell you where you are, it's about here, and unfortunately you, I don't know, bought too many cars or whatever, so you cannot get the loan that you want. So on this scale, it's a very local explanation, so it only handles one explanation, whereas some of the other models are more global in the sense that it tries to predict the entire model. And that is to go with the next slide, which is one of the first dilemmas, which is also related to that, where you can see linear regression and classification and logistic regression are on the bottom here of explainability. They have a high explainability, but if we want to produce it in more scalable environments, in more complex environments, they end up falling behind when it comes to accuracy, which is up here. So the models get more and more complex as we go on and produce higher and higher accuracy. So there's a trade-off between accuracy and explainability. More of, when you talk about explainability, there's also a trade-off between completeness and interpretability. So there's little words here. And what that means is that the explanation we talk about, now before we talked about the model itself, now we talk about the explanation. So the explanation here can be rather complete, so you can draw a lot of information out from the features that we're using to produce this explanation, and we get very complete image of what the model actually does, but it might not fit our level of intellectuality, and certainly not always mine. So instead, we might skip a bit on the completeness of information that we get and make it more interpretable. So the end user, for instance, a client in the bank, a patient at the hospital, might not get the completeness of his or her explanation, but the essence is there, right? Then the last thing is, so how do we actually form these explanations? Now we know there's something about accuracy and there's something about the completeness and how we understand it, but how do we actually then put it into use, describe it, visualize it? And so here's two different cases on how we as humans interpret explanations. And the first one is, well, I don't have kids, but I assume pretty accurate. So the word boy is a noun, and it can be described as noise with dirt on it. But it might also be a contrastive explanation where you say, yeah, it's the opposite to a girl. or it might be a social context where you are using the example here, where you try to put into context the situation you're in. So my boy is the one who's really dirty and noisy, right? So it really depends on the context you're in and who your audience is, the stakeholders that you're trying to produce explanations for. The other image here is from my recent case in healthcare, and it is much less informative, and especially for me because I have no background in healthcare at all. But this is a red boundary box, as they call it, and it's surrounding an area within a lung X-ray that is presumably infected with some kind of pathology, disease, edema, or it's 4 different pathologies. So there's different doctors who talk to the patient and different doctors who do the X-rays and different doctors who analyze the X-rays. So this is meant for mainly the ones who are analyzing the X-rays and describing them, so they know we should put our attention here and then try to describe this image. So I did this research project together with a girl called Millie. She's awesome, and we made it to a whole book chapter, which is coming out very soon in this book, Handbook of Artificial Intelligence in Healthcare. So to give a bit more context on what they actually do, this company provides a software that presents an interface similar to this, where we have all the different pathologies here listed here, and then they make a zonal assessment severity score. So they try to depict how huge or small a part of the lungs are infected, and what's the severity of that. And then you can kind of select lesion here and see where in the images do we find lesions. And what they then do is the doctors say, okay, yeah, sure thing, this matches, there's a lesion, we type that in further on, and it's supposed to effectivize their decisions. But what we then did was we spoke to the entire company and the doctors who built the model and the doctors who tested the models and the developers, and said, hey, so we kind of feel here that there's more to it than just the end user, right? So we made this stakeholder map of the different stakeholders who are in touch with this AI solution, and found out that they all have, of course, different roles, but they also have different needs for explainability. And these different needs form then into different purposes. So for the developer team, it's more about knowing kind of the feature importance, the correlations, and the model performance. Do we know if classes are skewed or whatever? Whereas for the decision maker, we saw that the humans, the doctors, had a tendency to rely too much on the software output if they were young doctors and inexperienced doctors, whereas they just told me that the software could also go in the opposite direction and actually make the doctors insecure about their own judgment and their own ability to detect different diseases if there were too many false positives. And those are some of the findings that we are continuously working with them on. So findings from research was besides that, there has to be a logic throughout the decision-making process and how you design your model and how you design your explanation. So the business purpose, the machine learning or AI model, and the explanation that you produce has to align with each other, because otherwise you get different kinds of purposes mixed in with different business objectives, and then you are screwed. Then you have to identify the underlying goal of the machine learning model and what you actually want the explanation for. Sometimes, for instance, in the financial case it's not beneficial to have explanation. It's not beneficial to know more about what the machine learning model does, because you might slack on your own human job, right? For instance, I'm researching transaction monitoring, and investigators get all our transactions that we make with our cards in a list, and they have to go through them all with equal attention to detail. But if they get a score saying, a machine learning model has said that this transaction is most likely not fraud, so I can just skip it and then call it a day, right? And then someone from the regulator's office comes along and say, hey, why did you not report this one? Oh, it's because the algorithm said, yeah, not gonna work, right? So you have to be very cautious about the goal of the model and if people need more information about that. So it's not always necessary to have explained the AI. Yes, and I think that was it for me. I'm on time? Yes. Thank you very much.
Thank you.
So questions?
Yes, we're going to try something else for questions now. I'll walk around with the microphone so everyone can hear. Yes.
I have a bodyguard. Thank you very much for the interesting talk. Could we go back to slide number 10?
Are you making me count?
They have numbers. Some of them at least.
Some of them have,
yes.
Yeah.
Yeah, so I'm interested in where this comes from, because explainability in itself and notion of explanation in itself is not really very well understood. I mean, philosophically speaking, even we have like many options there to choose from. So I'm just wondering, how did you measure or how did you come about this representation with the explainability going that way?
Well, I have the source here in my notes, so I can send you that. But mainly it's a visualization.
Mm-hmm.
So it's understood that we as humans have easier understanding, like a linear regression that we do.
So it has to do with our cognitive.
Yes.
Okay, it's not like a measurable
No.
AI. Yeah.
No, it's more like if you look at an output of a classification, let's say decision tree, that's easier to understand than if you try to support vector machine.
Yeah, just to add, I would find it extremely interesting to have like a really measure of explainability in a numerical sense, right? So assigning some sort of like
numbers are always nice.
Yeah, just it felt like it might be that. Thank you very much.
You're welcome. Thank you. More questions? Yes.
You seem to suggest that explainability will be available for any kind of model. And I would like to begin with the case of wolf versus husky.
Mm-hmm.
We could see the explanation while pointing out to the snow. So we could watch or see the picture and note that, well, this is snow that is being detected here. How about cases where you just have single pixels here and there that are not interpretable to human vision? And we know about cases where you have pictures with appropriately inserted pixels that will be classified, this would be classified as a cat or, I don't know, bus or what have you.
Mm-hmm.
What do we do in such cases? How do we explain this kind of, or is there any work done on this kind of, well, fake or cheating or misguiding classifiers? How do we deal with that?
Well, I will kind of tilt it the way around. So what's the objective here? Is it to detect artificially manipulated data? So is it detecting, there's a huge debate going on with generative adversarial networks creating images for profiles or, yeah, as you mentioned, just adjusting a few single pixels and then it suddenly detects a dog instead of a cat or whatnot. But those would still be explained in the sense that it only tries to highlight the pixels that it's using to detect what class this image belongs to. And you could say you would still have that in the other cases. But again, what is the objective? Is it to identify artificially generated images, or is it to detect what is actually in the picture? So I don't know if that answers your question. I think I heard two questions, and the other one was more, yeah, the other one was more like, can we get explanations for everything? And the cheeky answer is yes, but it's more of how detailed do you want it. So there's a model agnostic explanation that's more into this individual instances, explaining that as we saw with that one. So you can kind of add the surrogate model on top of almost every model. This line framework is, I'm a huge fan of it. So it's more on this local level, yeah. But if you want to know how, if we are ever gonna be able to comprehend and understand explanations of neural networks, no, we're not. We can make a small sample and then explain.
Thank you very much. Yes, we have one more question, and we have time for that.
Hi, do you think that the explanation part should be kept as a separate process that comes after the classification or the detection, or should it also somehow maybe affect the classification itself in a sort of a additional loop? Because in the case of humans, when we classify things, the fact that I know that I will have to explain this to someone when they ask, well, why did you choose this, or why did you decide to act like this, limits my classifications processes. And I don't know, maybe it's a problem, or maybe it's actually a good thing, this limitation.
Very nice question, and it's becoming a bit more complex because there's so many different ways you can use explainability, and I don't have a short answer to it. I would be happy to speak about it afterwards, but mainly it's a matter of the completeness interpretability dilemma again. So how much into detail do you want the explanation to be, and what is the requirement from your audience, from your stakeholders? And when you have assessed that, you can say, okay, do we want it pre-modeling? Do we want it in the middle of the model? Do we want to extract features from a neural network and generate that into a support vector machine, or a linear regression to make it really simple and then use that? Or do we want it all? Do we want it first when we have our data from our model, and then dig into that and have explainability of causations and correlations, and with less features that are too dominant, and then on the model itself, and then afterwards. So you can do everything. thank you very much for your time.
Thank you, Julie. Bravo. Can I have the mic back,
Yes.
please?
Please.
I'll introduce our next speaker as he's setting up his equipment. Jacek Malec has a PhD degree in artificial intelligence that he earned from Wrocław University of Technology in Poland. And after completing his PhD, he worked as a postdoc and a lecturer in a number of institutions in Poland and Sweden to finally settle down in Lund, where he is a full professor at the Department of Artificial Intelligence, the Department of Computer Science. His research interests are in artificial intelligence, particularly knowing representation of reasoning, robotics, and distributed systems. He's a member of many committees related to the AI, and yeah, as I've learned, we are pretty much neighbors. DTU and Lund University and DTU University are 1 hour drive apart, 87 kilometers, and you drive through a beautiful bridge between Sweden and Denmark that is 8 kilometers long. So that's fun.
Oh, here we are.
Here we are.
Okay. Thank you very much. Thank you for the invitation. Thank you for having me here. Okay. Can you hear me? Yes. Great. So I'm going to talk about AI, which I'm interested in for quite a long while now. No, obscenely long, I would say, since I was a student in some time last century. But I'm interested in AI not as a concept by itself, but rather as a tool for helping people, and helping people in different ways. So in my particular case, we do help people by letting them use robots in a simple, well, quite easy way. Oh. Oops, sorry. No. First of all, thank you for introducing Lund. It's a nice place just opposite the Sound. Actually, it was the first and the major archbishop site for Denmark and for the whole Scandinavia. So it's a place worth visiting, but last not least because of the university. Well, if you are interested in the university, I've got some more material about it, so we can take it in the corridor. So nice place to live, nice place to work, and nice place to think about robotics. We have a quite large robotic laboratory, and what we are interested in is to help people program robots. As programming robots is complicated, it's difficult task, especially for people who are not well prepared for this task, who have not sufficient experience with it. The idea is that you get your robot, say your service robot at home, and you would like it to do what you want. Well, probably you won't be so happy with programming it, sitting down by a laptop, testing, verifying, correcting errors. Well, there will be always errors, and I will be repeating it all my talk. There are lots of things to think about. Of course, there are sensors, actuators. You have to service them or take care of them properly. When we talk about robots, there are different robots. Well, of course, those robots you see on videos, YouTube videos like Boston Dynamics, dogs, and humanoids. But there are also lots of industrial robots of various kinds, and all of them have their peculiarities, have their properties that we need to take care of. And finally, last but not least, we have errors. There will be errors everywhere. There will be errors in programs, there will be errors in accuracies, there will be errors in actuation, and we have to take care of them appropriately. So let us begin with a very simple, well, actually flagship application of our laboratory. We have taken care of it, or we have studied it for more than 5 years. It's been quite a long, advanced European project. So in order to make this application run, or make this process of assembling this button box, stop button box, within the framework of the time that humans do it, some couple of minutes, we have spent, well, more than, well, first of all, we have got some 5 PhD theses defended on them. And at least 2 of those PhD students spent whole their time, PhD study time, on working on this particular problem. So of course, it's, maybe it looks trivial, but it's not trivial, because there's a lot of force information that is involved here. When you screw when you screw things together, you feel whether, well, you started properly, whether you finished it. It's quite complicated to first sense it, and then to transform your knowledge about what should happen and whether it happens or not into the actual program. So of course, there are lots of people who say, well, why won't we use machine learning, and in particular deep machine learning? There are lots of deep learning systems nowadays. Why don't we just learn to, for example, pick things? Here we see a case which it's been a Google lab set up some 5 years ago, maybe 4 years ago. I think it was 2018, where they studied, well, they just taught robots, or asked robots to learn to pick things. They did it for 8 weeks, 14 robots. They exchanged their knowledge, what they have learned so far, every night. So in a sense, you had an enormous speed up of learning while this experiment was going on. So we should have now, well, Google should sell its gripping programs or gripping skills to every robotic company in the world. Instead, what Google did was to close the robotic division. So, well, maybe not directly, but it shows that learning things just end-to-end using deep learning approach does not solve all the problems. We need something more, and this more, in my opinion, is just knowledge. So what we do in our lab, we are trying to systematize this knowledge. We are trying to introduce appropriate abstractions, and those abstractions that we are advocating to the world are so-called robotic skills. So a skill is just a collection of some primitives. Those might be movement primitives, those might be sensing primitives, might be control primitives, how to organize things together. And then we pack them together and we let them be used by the system. And of course, let them be used in case when the system knows what to do. So there must be some kind of goal, some kind of purpose, well, usually expressed in terms of task. And then the system reasons about what to do, how to use the skills it has in its possession, in its knowledge base, to solve that particular problem. And sometimes it works, sometimes it doesn't work, of course, and because maybe the robot does not know how to screw things together. So then it needs to be taught. So how can we teach it? Well, there are many things many ways of doing it. Before I go there, I'd like to show you the setup of our experiments. We have a robot with lots of sensors. It needs to be programmed. So up there you have the, here you have the code that runs this hardware. But this code needs to be created. And of course, in old times, a programmer, robot programmer would sit and write it. Right now we have interfaces for that. There are tools that help you doing that. We are developing this kind of tools as well. Then to the left, down in the left, you have this, well, actually a new version of a user interface for unexperienced users that helps us or helps the users to teach the robot what they want. But what's important is this cloud to the upper left, where we have the robot knowledge base. Well, it is in the cloud because we don't demand that it is sitting by the robot. It might be anywhere, of course. What's important is that the robot has access to the, well, quite large amount of knowledge about the world, how the world works and how it works in the world, in order to be able to do what we wanted to do. But there is also this word language up there. So what is it about? Well, we have in our group, we have a professor that does natural language understanding research. Well, actually also natural language creation, but that's another thing. So he has suggested us, why don't you use our parser? So we did it, and the idea is pretty simple. For every sentence that we can put into the system will tell us what the predicate is, so what is the action, in a sense, and what are its arguments. So here it doesn't make sense really create a Lego piece, but sorry for this misleading example. So let's, but what's important is that what we do is that we, for any verb, any predicate created or detected in a piece of text, we can identify it, we look up the vocabulary, we find out what does it mean, and then we cheat a bit. We look up our knowledge base and find out what does create mean in our robotic world, in the world that we have, that we understand. And of course, then we take the parameters and try to put it wherever they need it. So how does our knowledge look like? Well, it looks that there are different levels of this knowledge representation, but one of them is so-called ontology, where we have explicit, well, both taxonomy of how the world may look like, but also relations between those or among those concepts. So what are the, well, devices may provide you with tools for executing actions and so on and so forth. So there is much more to it. But what's important is that the robot, when it gets a piece of natural language, it tries to understand what is there, what do I want it to do. And here you have an example, well, quite old one actually. It's got some 5 years or so, where we tell the robot to take 3 of the needles and put them in the palette. So the palette is this gray area to the left. The needles are provided in a, well, crate or box. What's interesting here is that we are just saying, take 3 of the needles, and then the robot understands that, well, in this case, I need to, well, not only it knows where are the needles located, where is the palette, where to put it. It creates the program to do it. So this is the program created on the basis of this simple sentence. But it also understands that in order to take 3 of the needles, it needs to create a loop in the program that is repeated 3 times. So this was quite nice work, I would say. And we had quite much fun here. We were also developing this well, simplified. If you look at it, probably it doesn't look simplified, or it doesn't look so simple. But apparently this is a way of helping people, or it functions as a way of helping people to program robots, and in particular teaching them new skills. So this, it looks like follows. You have a robot that you are guiding to particular positions. You tell it, what is it, what you are showing it. So please note that Mai is talking here to the robot, or telling what is she presenting it. And then this way, this knowledge base of the robot may be extended with new skills. Although this is quite, well, tedious anyway. So here you see Mai doing this, well, quite simple task of teaching the robot to put a PC board into a frame of a mobile phone. So it takes time, and it's what we would like to do is, of course, to tell the robot, please put those two things together and then sit down and wait till it's done. But it's not so easy. There is too much knowledge necessary, and some things by themselves are, anyway, inherently complicated. So you cannot provide explicit knowledge about how to, for example, how to handle paper. Here we see a very nice application, well, putting or packaging a box as a parcel, just wrapping it in paper. So paper is inherently complicated to deal with. Every piece of paper will behave differently. And especially if, or they look the same, they behave similarly, but there are those small differences that we are not able to detect using our sensor, and in particular not in this case where the robot had no sensors except camera in its grippers. So it is really hard to make it to program this kind of application just by saying, well, please wrap it. Well, we need to provide it. Well, programming this took not 5 years, but 2 months, but still, it was 2 postdocs actually that did this application. And it took really hard, well, 2 months of hard work to get it work properly. So what I want to say is that even though you can program robots and we can have tools that help you program them, that can help inexperienced users program them easier, there will be hard problems, there will be errors that need to be taken care of. Well, we did some user studies, so we know what is the basic problem for people, for such users. But we are, well, quite far away from the moment when we can say, we can let our robot just be taught by telling it. I think it's still quite a long way to go. Although when you look at the achievements in other areas like GDP systems, GDP2, GDP3, those systems, conversational systems that, based on what you tell it, can program things, can generate piece of code doing really interesting things. Well, you can expect that at least the programming part will be achieved pretty soon. But what we need is this knowledge about the real world, about how the physics of the world, something that we as humans learn in our infancy when we play with things, when we learn that things fall down, when slipped, when we learn that water, if I turn my glass, it will pour down, and so on. So all that knowledge is still, in principle, inaccessible to most of the systems we are looking Besides, well, we have done some attempts to make this kind of activities generalized. So what we would like, after the robot has folded paper on one side of the parcel, we wanted to tell it, please do the same thing on the other side. Well, it's obvious. When you just turn the robot to the other side and do the same thing. Well, what does it mean? Well, is it what kind of symmetry you want? Is it the mirror symmetry? Is it point symmetry? Is it axis symmetry? Because you have many different possibilities. And of course, in this case, we just have two possibilities. And the robot needs to understand which one should be taken. Or at least it should be able to talk with me and ask me, what do you want? Which one is reasonable? Yes. What we have learned during that process, natural language is not, even though it is a very powerful tool to tell the robot what he wants, it is ambiguous and it is not always clear, crystal clear what you want. You need the robot to understand the world. And this understanding is not a trivial thing, of course. There will always be errors, and you need to be prepared for taking care of them. There is no way that, that your system you are building, be it the explanation system, even explanation systems won't be 100% foolproof working correctly. So we need to be prepared for them. We need to be able to use vision. We need to be able to take care of the force. Let me skip that. Talking about generic learning, like the one you have seen in the Google in the Google video, is not serious at this moment. There is quite a lot of work before we are there. We want the robot to understand their failures. And this is, well, first, in order to do that, we need to let the robot, we need to understand what is a failure in the first place. Sometimes it's not clear what it is. We need to have explainable models. We need to produce accountable and trustworthy systems. And finally, it's a very interesting area because there is a lot to be done, and it's developing very actively nowadays. Just to finish, it's half a minute now left. This is our group, it's Robotics and Semantic Systems group in Lund. We do AI, robotics, natural language, machine learning, pure machine learning, and we have a robotics lab, this red stuff, together with another department. We have a spin-off company. We have 2 more spin-off companies on the way. And we have a number of robots, of course, some 20, 30. This is our new requirement here on Robot. And of course, there are lots of people that made this work possible, that made those results to become interesting and useful. So thank you very much for your attention. Sorry for taking a bit too much time.
Thank you very much, Jacek. We have time for 2 questions. Nina.
Thank you very much for the fascinating talk. We now acquired 2 Pepper robots in our lab, and we are, I mean, not me, but Thomas Bolander is doing second order beliefs. So beliefs about, we have 2 robots, they reason about each other, which is very fun to watch. You said that you represent skills as state machines. I was wondering, how does it relate to STRIPS planning, and is it based on the classical paradigm on actions, or?
Yes, so you can, sorry, maybe you can want to finish.
Well,
or is it?
I was just curious about that. So to what extent they are, what kind of state machines they are? Is it like regular languages, or Are they like descriptions in first order logic? That's one question. And then related to that, I was wondering, you actually addressed it at the end, to what extent the stuff that you're doing actually is transferable skills. But you said it about the paper that there's a lot of issues there. But I was wondering how you tackle this particular problem of general intelligence, like transferring between different domains.
Okay. So the first one, yes, we are using classical planning on the higher level. So where you can imagine skill as an abstraction on different layers. It's or looking from control theory perspective, it's a hybrid system. You have the continuous parts down there, and then those continuous elements are orchestrated by some kind of state machine up there. And then the skill would be on that level or above that level. You can have abstractions or hierarchical planning. You can imagine this as a kind of hierarchical planning. So you can use strips, although strips is not very efficient, but well, the idea is there, of course. You have logical or at least some kind of semantical description using some kind of formal system up there, and then you reason there in order to find out, for example, how to schedule your skills in order to achieve some goal. So yes, that's this is, what was the second? Transferability. This is a tricky part because you need to know physics of a particular mechanism in order to be able to transfer. So if you have, well, in our case, we did it for in a small scale for this Yumi robot, two-handed robot with 7 degrees of freedom, so with an elbow. And then we try to transfer the skill onto a robot with just 6 degrees of freedom, so no elbow, and just one hand. So how do you do screwing using just one hand? Well, of course, you need to have some device that would serve as the second hand, some kind of fixture. So, and all that is knowledge that you need in order to be able to transfer this screwing skill from one robot to another. So in your knowledge base, you need to have, or your robot may come with it, maybe from its producer, saying, well, in order to do that, I need a fixture of this kind, and then I will be able to screw. But this is knowledge that needs to be loaded into the system somehow, told, programmed into it before you can do this. And of course, that's unavoidable, I would say. There are people who claim it may be learned, but I'm doubtful.
Thank you for the amazing talk. And I have one question. So you are trying to pretty much create robots, like, well, way for robots to be programmed with language.
Yes.
And as you mentioned, there's a lot of errors. What about programming robots to, like, so that the human can explain in language the error and the robot can interpret it for the future? Like, is there any work done on it, or?
We are not doing this kind of work, unfortunately. We don't have resources for it. But if I understand correctly, there are people, there are groups that are looking at a conversation with robots that is leading to understanding to draw conclusions from failures. Let's put it this way. I do not recall at this moment directly a case that you are talking about where you would tell the robot this was an error because this and this and that. Although, of course, this is what you want. Okay, thank you.
Thank you very much. I'll kindly ask Nina to approach and connect, please. So let's go. Nina Gerasimchuk is our final speaker for this session. Nina is an associate professor in logic at the Department of Applied Mathematics and Computer Science here at DTU. I've met Nina yesterday at the meeting in the Polish embassy, and that's already showing that this meeting is really expanding our network. It did expand mine. I work here at this university and had no idea Nina was working here too. So I'm very excited about that. Nina holds a PhD in computer science from the Institute of Logics, Language and Computation, University of Amsterdam. Her main research interests lie in the logics aspects of learning in both single and multi-agent contexts, and involve computational learning theory, model logics, and computability theory. She will speak today about different aspects of online learning as soon as we connect.
Yeah, sorry about that. I should try it.
That's okay, no problem. Right.
Yeah, and this one? Ah, okay, cool. Thank you.
Please join me in welcoming Nina.
Thank you very much. Can you hear me well? Yes. Thank you very much for your kind invitation, and I'm also super happy and excited to meet all the DTU people that I just somehow missed in the cantinas here, or I don't know how that happened. So I work normally on learning and belief revision, so a little bit about knowledge representation, what was kind of addressed before. I believe in machine learning to some extent, but I also believe that our symbolic methods of understanding both human reasoning, but also potential machine reasoning is super crucial, and this is what I teach here as well. For today, I chose to talk about a more applied area, because I thought maybe that would be more interesting to you guys. And that's old work that I did between 2011 and maybe 2015. And now I'm still continuing with that in many different ways. And it has to do with education, but it also has to do with logic and reasoning and a little bit with explanation as well. So I hope maybe in the discussion we can also touch upon different previously mentioned topics. So there is this issue of literacy in general, right, in society. So we would like people to be able to read, write, and also understand each other and share some sort of common space where they can communicate with each other. And well, we would like it to be as rational as possible. And here is where formal literacy comes in. And this project that I was involved in, it very much touches upon that issue. So from the very early age, we would like children to be familiar with certain concepts like mathematics, less obviously logic, and nowadays very obviously computer science. That's something new here, right? So this part here is something that we acquired recently. Mathematics was always recognized to be somehow important. Logic is a strange place. People recognize that it's something that we need. When you're on social media, you realize that people actually don't have that much logic, maybe, or they're not equipped with that much of it. And it's also quite difficult to understand the importance of logic. But logic is actually bridging a lot of topics in mathematics and computer science, or at least on this sort of like fundamental, humble level. It's not very hype, but it's extremely important. I hope Professor Moritz agrees with me. So anyway, I will be talking about computer-based education of these formal skills. When I was in the Netherlands, I was involved with the company called Oefenweb, or also they developed a product called Math Garden, so it was a little spin-off, a company of that one. And what they do is that they provide an adaptive training environment with educational games for children in schools. So that's very early age. We are talking like from like I think 5 years old on. And the goal of this project is to develop abstract thinking in children through game playing. The idea is that kids can play these games daily. It's a little bit like mobile phone apps, very simple games. And this is taken as an input for monitoring their progress in learning certain things. And this is the overall scheme of our project. So we have, so I was here among the investigators. We had the online domain of madgarden.com where kids could go and play games. They were here, they were playing games. Then the reports of their game playing progress would go in form of reports to the teacher, so to the actual teacher in the classroom, who would give instructions. This stopped working now, yeah. To the student. And we were somehow involved like in the middle. So we would be able to gather data from the progress of the kids from the system and then enrich it with new tasks and new items so that maybe the learning process can be kind of enhanced or controlled in some way. And we also were, of course, given the ability to influence what the teachers were doing in the classroom. So the idea here was not to replace the teachers and the human contact in the teaching process, but rather give some sort of enhanced possibilities of learning with the computer system. So here you can see the scale of the project. This is a map of the Netherlands. So Amsterdam is somewhere there, where there are a lot of those bins. At the time when I was involved with the project in a couple of years, so it was around 3 years, we had about 1,000 schools enrolled in this project. We are talking whole schools, so they had contracts with our company, and they actually made their kids play, not forced them, but they played the games. And in this time, we received 250 billion data points of games being played, right? And here you can imagine, even not working in the field, you can imagine how much potential this holds, right? Because you can see a lot of stuff there. And we had 80,000 active users in this period. The game looks like this. So now it probably changed since I worked there, but the idea was that it's a math garden. So we have flowers growing, and they grow as much as children practice the certain skills. So we have addition, the minus, the multiplication and division, so certain mathematical operations that the kids can train. And you know, the more they play, the nicer the flowers look. So it's a little bit like incentivizing them to actually maintain their garden. And the games, individual games, they look a little bit like this. So this is a very, very simple game. And the kid just has to pick the answer that they are looking for. And the idea is that we have coins here, and they disappear with time. And at the moment when the kid gives the right answer, they receive the amount of coins that is left in the screen. So that's kind of the measure of the ability that takes into account both accuracy and time. It's all psychologically kind of justified. So what is adaptive about the system is that we make the students play at their level that is suited for their actual ability. And their level means that they are able to do 75% of the tasks at a certain level. So we want to keep it challenging for them, but not so challenging that they would give up. Okay? So you can manipulate that threshold. And what is important is that the task's difficulty and the level of the student is continuously estimated, continuously adjusted. As kids learn, the system understands that they're actually progressing in their ability and feeds them more complex items. And what is extremely important here, that this complexity or difficulty of items does not come from us, what we think is more complex, but it rather comes from the system itself. And how it's set up? We are using the ELO rating system that is known from the chess playing environment. And I don't know how many of you are familiar with ELO rating system? The system works as follows. So chess players are assigned certain ratings. And now if you put two players play against each other and somebody is really very able and somebody else's rating is very low, and this person wins over the other one, then of course their rating increases a lot, right? Because they were able to defeat a very good opponent. While of course if they play on the same level, then if they win against each other, the ratings don't get upgraded so much. So here the trick is that we actually used children on the one hand and items, games on the other, and we rated them against each other. So if a child solves an item, then it gets ranked above the item, right? And then we have a combined list of items, games and children, and we can disentangle them and have a rating of kids and rating of items. It's a very interesting way of measuring things because it's psychologically valid, it's cognitively interesting, but it kind of lacks also this explainability element because we just got it from the gameplay, so it's a very behavioral element. What was my role in particular was that, well, we all realized that you know, addition, multiplication, things like that, they are very important, but they are not everything there is to learn about formal skills. So critical thinking and logic skills are extremely important. But that's something that is very hard to grade in high schools or in schools because people associate logic with natural intelligence. So if we would go to elementary schools and start judging kids on the basis of how they actually reason logically, the parents would probably very quickly get upset at us that we are, you know, ranking something that is maybe untrainable. And that's a kind of very conservative way of thinking about logic, that it's something that is kind of natural equipment that it cannot be really trained. But we thought maybe it can be. So my role in the project was to enrich and propose new games that are on the kind of more logic level. And I don't know, probably you are familiar with Mastermind. Just at the end of communism, the game was in my home, so I suppose it was also in your homes. Yeah, it's a very popular game. For those of you that don't know it, we have a code maker and code breaker. So code maker makes a secret code of pins here, and then the other player sits on the other side. They cannot see this part, and they make successive guesses inductively one by one. And each time they make a guess, the code maker gives feedback. And this feedback is in a quite complex logical form. It's kind of existential statements. The white pin stands for the right pin in the right position, and the red pin stands for the right pin but in the wrong position. So it's there, but it should be someplace else. So actually on the logical level, it's not that easy, really. I mean, yeah. So the idea was, okay, there is a lot of stuff here, and it's also, again, with a huge potential because it could be developed into single-player version and maybe also involve some social skills. But we thought, let's start with this one, but first we have to somehow single-agent it. And because those games are online, kids play them by themselves, so we have to remove the role of the code maker, perhaps, and make children play the game independently. So this is what the game looks like. It's called Flower Code, but it's actually a disguised mastermind game. I call it deductive mastermind because it doesn't have the inductive element that the other game has. So what you can see here is that a kid is already provided with a bunch of premises in form of these possible guesses. So it's like they join the mastermind game at the end of it, you know? So we already have premises, and now the child is supposed to take the flowers from the domain and propose them as a solution and press OK. And again, we have this disappearing coins. The cow and the pig don't play any function here, so just so you know. And then here we have this coins that disappear, and the moment that the kid makes the right decision, they get this amount of coin. Importantly, when they make a mistake, they actually get the amount of coin that is left subtracted from their stuff. Which was quite unpleasant, but it turned out that psychologically speaking, this makes a lot of sense for our project. By the way, the kids were able to use these coins for the local shop, so they could buy sweets and stuff if they succeeded. Okay, so far fun and games, and nice. It was actually a lot of work to implement this game, and we had huge discussions about how feasible it is, what to do with it, and so it took a lot of time. And then we implemented it, we ran tests, and finally the game went online, and it was one of the most popular games, of course, because, you know, addition, multiplication, they are quite boring. But this is a little bit more kind of like something that you could get addicted to. And what was my own personal success was that I actually saw the data that kids play this during Christmas. So even when they're off school, they would like play this at home. And what you can see here is an example of one very complicated game and one user. So this is a super user, number 163545. And this particular user played this particular game 3,601 times. Okay? Crazy, right? But the thing is that the game is so complex that it's not boring because you keep going back and forth within the difficulty levels. And you reach certain level of difficulty and then you fail at it, you get pushed back. So then it kind of was a very critical point for the student probably. And here this game looks quite complicated, right? We have this like flowers in 4 rows of 4, and the feedback is quite complicated because it differs across different elements. Yeah, it's difficult. And here you can see the progression of the student's ability over time. I actually have a magnify. I wonder if it will work. Yes. So here you can see the guesses of the child in this particular game. The green data points correspond to the correct answers, right? So the correct answer is actually red, yellow, red, yellow. So tulip, sunflower, tulip, sunflower. You can see where they make a mistake. So in the beginning, they were kind of randomly guessing, maybe trying, you know, when they press question mark, they actually get the answer. Then after a while, you can see that there was something, on this line here, we have reaction time. So this is how long it took for them to come up with the answer. So what is interesting here, I mean, if you need explanations, we were talking about this quite a lot, you can see that perhaps in the beginning they were just chancing it, and then they started thinking. So there's this increase in reaction time. This is like reasoning happening here in this point, and the right answer, right? Then there's a giving up again, there's thinking a lot again, solving it. Then there is some time for the right answers. Then there is some mistake, a lot of thinking again, a mistake. And after a while, maybe it becomes more like machine learning-ly thing, right? That it actually becomes pattern matching. They simply remember the game and they are able to quickly, on average, they were able to respond to this task. So what you can see is probably that symbolic AI or symbolic kind of components of AI is actually what in natural reasoning happens around here, and after that we have sort of probabilistic matching. So something that is on the maybe lower level of perception rather than, you know, different system. So we were able to access things like that, and not only these things, we were able to access things like correlation with other games, correlation with the social context of the child. I mean, you can see how well they perform on different dates, depending on, you could see everything, right, in this data. Of course, we didn't abuse that, so we only checked for our hypothesis, but you can imagine that such systems collecting data about students can really help the process if they are interpreted in the correct way. But of course, there has to be a human involved that, corrects the machine. Here we have the outcome. My interest, personal interest in this project was to look at how we can access the complexity and structure of logical reasoning through this experiment. So what is it in those games that actually people do, and what makes it difficult to do? What makes logic difficult? I mean, you know, it's a general question, maybe too general for this particular project, but yes. And interestingly, what we found is that the ability to play mastermind is not a like usual abilities. So it doesn't follow the bell curve in the sense what you usually have in you study abilities. You can say that, and also in grading, when you grade on a curve, you know this very well, right? So you're supposed to have not many students at this level, a lot of students in the middle ability, and then not so many at the end. But now what came out from our simple game experiment, maybe it wasn't simple enough, was that we actually got bimodal distribution. So in our case, what we got was this. Oh, maybe I'm exaggerating, like this. So we got 2 picks of performance. Well, that's just a rough picture. But the idea is that it somehow didn't follow the usual way of thinking, which is also very instructive. But here, in this picture, you can see it very clearly, I think, in this divide. So you can see those points are actually games that kids play, and different shapes correspond to different number of colors, so different number of types of flowers. So the diamonds were the most complicated ones with the different kinds of flowers in them. And the colors correspond to the number of pins in the gases. I'm sorry for that, it's a bit difficult. So the light blue ones were the most difficult ones. The ones that we saw just a minute ago was one of the dark blue, right? So what we can see is that across different measures, the size of the gases and the number of flowers, we have easy items and difficult items. It was very difficult to isolate a parameter that makes a logical task difficult, which was like amazing for me, because I thought I'm doing something super, mundane and basic, like implementing an app for kids. But suddenly it turns out that there is something going on there that was kind of quite puzzling. And here I'm not going to go into details of these measures, but I thought long and hard about how to analyze this problem. And I thought maybe the Tableau's method, for some of you probably know from discrete mathematics or introduction to logic, for propositional logic would help analyze those phenomena.
Nina, 2 minutes left.
Yeah, thank you. So here we can see the 2 items with the corresponding reasoning trees that you could assign to them. And you can clearly see that even though the items are very similar in terms of sizes, they're actually, the one on the bottom will be more difficult for kids to solve than the one on top. And logic, like theoretical modeling of this, gives a very concrete justification in terms of an iterative algorithm that gives you the number of steps that corresponds to that. We were interested in 2 things at the end of the project. One was explanation, and here I will try to play, I hope the sound will work, I will try to play what we actually thought of explanations and how they would be useful. And what we did, we asked kids to explain what they were actually doing while playing this game. And here is an example of that.
Hier zie je alle bloemen waar je uit kan kiezen. Er staan allemaal groene en rode lampjes, geen oranje lampje. Het kan dus zijn, je kan heel goed dat hier, want dat is allemaal, dat moet wel groen zijn, want dit kan niet allemaal groen zijn. Dan is het dubbel op elkaar en dat kan niet, want dit is allemaal hetzelfde, dat moet dat zijn. En hier, alles is hier dus fout. En de enige die dan nog niet is gebruikt is deze. En dan moet dat dus goed zijn.
These things and we analyzed it. That's a different part of the project. And what we also looked at is errors, something that logic usually overlooks as an important aspect of modeling. It's looking at patterns. What kind of errors kids make most often and why? And to some extent, the reasoning trees that we had actually explain this bad paths that kids take. And here you have representation of this problem. We have 4 different tasks, and you can see that the logical structure actually corresponds to the type of errors that they make. So if the items have logical structures that are similar to each other, then the errors will be very similar in nature. And finally, we also looked at different ways of explaining things that actually corresponded to eye tracking experiments. So here you can see a different version of the same task. And those lines here and dots, they are actually focal points, the places where kids looked at when they solved the items. And the idea here being that the attention... Oh, it's fine. I think you can hear me, right? I can speak up. The idea is that, thank you, that the kids actually look at places that they think about. It's a bit rough and crude idea, but you could kind of approximate how the explanations and the actual reasoning while in the game correspond to each other through this process. So this collaboration ended I mean, I did follow-up studies with different logical measures of difficulty to check if the data actually agrees with that. I also worked with the Center of Applied Games and KPMG actually for the education on that. And here in Denmark, I work with DIALOG company who provides mathematical education for high school students. Thank you very much. I hope this gives you some sort of insight into well, computer science in education. Thank you very much.
Thank you, fantastic talk, very interesting. Thank you, Nina. Questions? Yes.
Can you explain the reason for this bimodal distribution?
So it turned out that, simplifyingly, okay, because it's hard to, when you reason with AND, like P and Q, two things that you have to go through, you can basically sequentialize it anyway. When you reason with OR, the problem is that you have to branch. So in the game, it's like, I look at the feedback and I say, okay, it's either that the tulip is correct or the sunflower is correct. Assume the tulip is correct, reason down. So the disjunction, what it does is it creates branching in the reasoning process. And so the kid has to, when they go down this path, they have to be able to backtrack and go there. So I thought that probably this would solely explain that. The fact whenever disjunction appears, then things become difficult. But it's not that easy. So what actually happens is that the feedback levels were as follows. So whenever we had red and orange feedback together, so the negative information that something is wrong, and orange feedback that something is right but in the wrong position, this was the most difficult part because you had to both remember and deal with negation at the same time. So it was an interaction of these two elements together that really well predicted where the item will be placed. But then you can still ask, you know, it's not a really single explanation, it's a combination of factors from a logical perspective. So we have that, and that's modest, but I guess this is as far as we can explain it for now.
Thank you. I have a question. You say you could see what days they were playing the game, right? So did you find any correlation of how well they were doing on days when they were, let's say, school days and weekends? Because I don't know if there's any, I wonder if there's any influence of how tired they are or how much they use their brain already before they play the game.
I don't know of that. I remember that we had some insights and there were some issues even with analyzing the data that didn't come from schools because, you know, like we had these privacy concerns. Like when they're at school, they're doing it really for the school. Otherwise, I don't know. But I think it was overall very kind of normal progression. So it wasn't very skewed by certain moments like in the school year, like Christmas or something. But I can check it if you want and just tell you. Yeah, but it's a very good question.
Yes, I have one more question. Have you looked to compare if children who play this game perform different in their education compared to children who don't play the game? If the logic is transferable?
No, I did not. I think that now they have also the version of this game for linguistic skills. And I think that would probably be a little bit more interesting to look at because they learn grammatical structures there. And as we saw in the parsing situation, it has much more to do with trees and with the representation of that. We saw, of course, the large correlation between mathematical skills in general and this logic thing. But you could argue that it could be all sorts of things. For instance, the ability to focus, right? I mean, if you're able to focus with math, perhaps you're able to focus with logic. But I think this game was much more popular than the other games. So maybe that also says something, right? Yeah, I think it's possible to do like long-term study and see how kids perform later on. Thank you.
One more?
Okay.
Do we have time, or I can ask it in the coffee break?
Yes, maybe in a coffee break, okay. I would like to ask all the speakers to come to the stage one last time. Speakers of this session, please. We have little gifts for you. So, please, let's applaud. It was a great learning experience. Well done, everyone. Thank you so much. There's chocolate, yes. Here you go, and some gadgets from Polonium Foundation. Thank you. Thank you very much. Thank you. Yay. Fancy. Chocolate and gadgets. I am not from the AI field at all, but what I'm curious about is how much do you collaborate and how much do you share your data? In general. that look tells me a lot. Thank you. Because in life science, actually, in programming, a lot of data sharing is happening, I find. But here, I'm not. Maybe we can talk in a break. Yes, we are back in 20 minutes, all right? Yes. Thank you very much. Yes, 20 minutes. 20 to 12, please.